Assalamualaikum and salam sejahtera. My name is Norlidyana binti Khalid and I will be presenting to you. Introduction. Partial derivatives of a function of several variables is its derivative with respect to one of those variables with the others held constant. Partial derivatives are used in vector calculus and differential geometry. The symbol shown used to denote partial derivatives. Marquis de Condorcet from 1770 is one of the first person to use this symbol in mathematics, where he used it for partial differences. Adrien Marie Legendre created the modern partial derivative notation in the year 1786, which he later abandoned it, and later the symbol were reintroduced by Carl Gustav Jacob Jacobi in 1841. Partial derivatives are very useful in calculating and analyzing surfaces for maximum and minimum points and rise to partial differential equations. As with ordinary derivatives, a first partial derivative represents a slope of a tangent line or a rate of change. Two first partial derivatives would represent the slope in each of two perpendicular directions for a three-dimensional surface. Second, third, and higher partial derivatives give more information about how the function changes at any point.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dayang Shakilah and I will be presenting the problem statement and the calculation. Okay, I'm going to present about the problem statement. So a construction project about to start and requires to remove water from an old 18 diameter of water tank to a new place. But first, the water tank needs to undergo an emptying. So here we got the tank modeled by the equation dV over dt equals to 3 exponent to the power of negative 2.5 times 10 power negative 3 t. So as an engineer, want to know how the height of water changes with time. The radius of the water tank is 9 meters, and if the tank left for a minute, what is the rate of height changes? So here's the solution. From the problem that we know that the volume of water tank of a cylinder water tank by the formula of V equals to pi r squared h. So we differentiate or derivate the volume of water tank by the height. So we got dV over dH pi r square. So we'll continue. We insert the 9 meter radius inside the derivative of volume formula that we already get. So we got 81 pi. So from the information we have, we can form a chain rule equation to get the dH over dt. So we got dV over dt equals to dV over dH times dH over dt. We insert the data that we have inside this equation, 3 exponent negative 0.0025 t equals to 81 pi, which is the dV over dH times dH over dt. We transfer 80 pi to the left, so we got divide 3 exponent negative 0.0025 t divide 81 pi equals to dH over dt. So dH over dt we get 0.01179 exponent negative 0.0025 t. We continue. So the question, from the question, it says that the water tank left for a minute. So from this equation, we can determine the height of water at time 1 minute. So 1 minute equals to 60 seconds. So we insert the 60 seconds inside the t parameter. So dH over dt equals to 0.01179 exponent negative 0.025 times 60. So we get dH over dt equals to 0.01015 meter per second. We change it into centimeters, so we got 1.15 centimeter per second.
In conclusion, from the calculations and solutions done, we have gotten the answer to of rate of height is 1.015 centimeter per second. From this project, we have discovered that the usefulness of partial derivatives in engineering work and how important this knowledge is.